my advice, if you're working on these responsible AI approaches, is to bring these groups together early on. Don't let it just be something completely isolated, because without that context understood by the people that are actually using and delivering this project, it doesn't matter how well your algorithm performs. It doesn't matter that you got the algorithm to perform really well across all these racial groups if at the end of the day, when somebody's actually using the thing, they're going to ignore the outputs. So that context has to be established. That agreement has to be established. As hard as it is, that understanding has to be established for it's not just responsible AI, it's responsible organizations.
And now, from San Francisco and the UCSF Rosenman Institute, the Health Technology Podcast with your host, Christine Winoto.
Our special guest today is Chris Hemphill. Chris is the Vice President of AI at SymphonyRM and an expert in the field of healthcare data and analytics. In this episode, Chris explains how systemic biases in data collection can affect how companies care for their patients. We discuss how these biases can impact underserved communities and look towards some solutions. Here's our conversation. Well, welcome, Chris. Thanks for joining me this morning.
Appreciate you bringing me on.
Yeah, I'm just so excited to share your story and your expertise with our listener. And I thought it would be good to start to share with our listener about your background, what's your journey, personal journey, and professional journey, how you get to where you are today.
Well, I appreciate that and excited to share that background. Thank you for sharing the background of this audience, and hopefully there are some parallels and people might find some inspiration to follow a similar path. The more people in data science, the better, in my opinion. So my career actually began a little bit differently. So even though data science right now, I started out in sales at this healthcare analytics company. But over time, while I was in college, I was really interested in things like Freakonomics and the types of insights that people were finding from data. So I thought healthcare analytics was a good path. But over time, I became more interested in going into actually conducting the analytics and the economics and things like that themselves. So I migrated from sales into sales operations, which was a more analytic role. But I got really jealous of what my friends were doing in data science, taking large data sets, making massive predictions, the types of insights that books like Freakonomics, Everybody Lies, Weapons of Math Destruction, the types of insights that were coming from those books highlighted a really strong power of what you are capable of doing with data science, and then seeing it, making it more accessible, seeing that I had friends that were doing that as well, really inspired a journey down that path. So studied heavily in that area with General Assembly, while at the same time taking on projects within my work environment. Ended up teaching a class at General Assembly in data science because I'm so passionate about that work, and taking a lot of what was learned, a lot of what was applied, using that immediately, and then that's kind of transitioned into my current role, which is focused on data science itself, but also communications around what these capabilities are and strategies on how to approach these issues. Of course, effectively, you want to be able to drive results and communicate with leaders about the results that they're capable of driving, but also ethically, looking at kind of the fork in the road where we are now, where we see that in our history, like within healthcare, within our economies in general, but all the way down to within healthcare, there has been a history of biased delivery and biased perceptions across the lines of race and gender on how we communicate with patients, whether or not we believe their stories, what we ultimately code them for, who can afford care or not, who has the time to take out care. Well, all of that kind of stuff manifests itself within the data sets, like on the data science side, all that historical bias from economies and from business practices and processes, it manifests itself in terms of how data sets are imbalanced, how much care people are consuming. And that is a really big key to what I'm focused on addressing, what we're focused on addressing. The company where I work now is SymphonyRM.
Okay. So there's so much to unpack what we are saying. One of the things that caught my attention when you're saying about historical biases and what do you mean by that? And then how can we change that or do something about it?
That's a great question. How can we do something about it? I love that question. And to help with people that might not be familiar with like the types of bias that might be entering our data, there are a couple of biases that I'll focus on here. The vocabulary, the words of the day are systemic bias, financial bias, and label bias. Now, what does all that mean? Systemic bias means that if there are differences in the ability for people across different classes, such as white patients versus Black patients versus Latinx patients, or male versus female, woman versus man, or how people express their gender identity, if there are differences in how that care is delivered or the types of access that people have, then and basically if there's some groups that are underserved, they have needs, but they don't have the ability to access those needs, well, that's an overall systemic bias. That's a reflection of if I'm on the wrong side of the railroad tracks, if I come from a certain region and somehow care is less affordable or less accessible to me, systemic bias points to bias that's within the larger economic system, filtering down to our healthcare population of interest. The second form of bias that I mentioned is financial bias, which which is basically it's what it sounds like. If I'm able to afford services, then I'm more likely to come in. If I'm unable to afford services, then I'm less likely to come in. You combine systemic and financial bias, you combine the lack of privilege or lack of economic opportunity that certain groups have, then you start looking at the ways that bias might be present within the data that you're looking at. I can talk about label choice bias a little bit further, maybe even further down the road. But basically, for label choice bias, I think that's probably the most unintuitive, unfamiliar term that I'm introducing. But what the easiest way to think about it is there's a common phrase is that your algorithm, like within AI or within whatever you're trying to do, your algorithm is no better than what you're optimizing it for. So label choice bias is an example of what am I optimizing for? What am I trying to get this algorithm to find out? And like what you're optimizing your algorithm for is called a label. Let's say, and here's an example that you might have read about that folks you could Google it right now. If you Google Scientific American racial bias in AI, then you'll find a study from 2019 that went over the significant challenge that label choice bias introduces. And what happened in this study is that the algorithm, what they were attempting to do was identify the sickest patients and make sure that those sickest patients were within a particular intervention, receiving communications and coming in for a particular program. To find out who the sickest patients were, they used a proxy. They said, okay, well, if we see that this patient over the past few years has spent significantly more than this other patient, then we can assume that they have a higher set of health risks, that their sickness is much higher. But what's the flaw in that approach? Is that it introduces a financial bias, because our goal is to figure out, hey, which patients are the sickest. And it does seem intuitively like a good assumption. Well, if somebody's spending more, they're probably accessing care that's more expensive, the acuity is higher, or they might even be accessing more frequently. So the higher spend would indicate that that person is sicker. But the problem is, what about the financial bias? What about the systemic bias that prevents people who are equally sick from being able to engage in that spending? So by doing that, what the people who did this study had found, and those people, Dr. Ziada Obermeyer and a team working with the Chicago Booth School of Business Center for Applied Artificial Intelligence, what they ultimately found, but when analyzing what the algorithm was doing, like, hey, here's our hypothesis, there might be some bias introduced by using that financial cost as a label. And what they found was that Black patients needed to be it was flagging Black patients who had needs at a significantly lower rate. They said, okay, well, how do we? What's another way that we can actually get down to how sick somebody is? And they changed the algorithm rather than using cost, which I could understand why somebody would make that assumption that would be a good way to do it. And I'm not saying that the people who were developing the algorithm are part of the Ku Klux Klan or doing anything malicious. It's just an example of where innocent teams, people who might not believe or might not even want to, of course, wouldn't want to spread racism, end up doing it anyway because of there just hasn't been the rigor to start breaking these things down by race and seeing how they impact. But they changed that label from cost to comorbidities. Comorbidities being the number of illnesses that someone has. So if somebody had been diagnosed for a higher number of illnesses, they use that as the adjusting risk factor rather than cost. And by doing that, they actually doubled the outreach, doubled the number of Black patients that were coming into the program, likely because they had found a way, a number, a metric, a label that more closely represented how sick somebody actually was and removed a lot of that financial bias component.
So measuring the comorbidity seems removing the financial kind of biases, but at the same time, it's assuming everybody who have comorbidity at least been to a doctor once. So then that's why they're always got captured.
Yeah. So, and that's a really valid point too, is that even like because Black people or because certain ethnicities or races are less likely to visit health systems for a variety of reasons, I would argue, of course, that there is still bias in that approach, and the concept is to reduce the amount of bias, or at least identify and quantify and find interventions based on the amount of bias. So if we do get to that part of the conversation where there are approaches beyond taking something like label choice bias or financial bias and looking at that, then I'd be happy to talk about different approaches around that too.
I think it's always a work in progress, right? I think before, like you're saying, using the financial as the metric, thinking that, people who design it thinks that makes sense. You spend more money, then you see a doctor more because you're sick more, only not to realize that there's other people, even though they're sick, because of a financial situation, they don't seek out a doctor. So then get corrected. So I'm sure even when we measure the comorbidity as we evolve, I'm sure there's new things that can be introduced to make healthcare more equitable.
That's correct. So, yeah, and I love the term work in progress. The operation meaning the progress has to be there. We have to acknowledge that these approaches using data, using machine learning, using AI, using instinct and gut, all of those have the opportunity to introduce bias, but we have to acknowledge that it's there and work on it.
And so you mentioned, I thought it was interesting about the label bias. And that seems to be the key in terms of how you change the mindset, because that changed everything, the algorithm that determine what is included and what's not. And how do you create a knowledge so that when people come up with the label, it's the right label.
Great point. So that's when we were working along these approaches, there's kind of a path that you can take, because there's all kinds of different labels we could use. We could use something like cost. We could use things like number of visits. There's all kinds of different labels that you can use. But the biggest point is it's not necessarily something that you just select by intuition and just go forward with it. You actually, when you're developing your approach, look at the label. Look at how look at ultimately what the model is recommending. Look at the output of the model after you've made the change. So here's an example. What if we had used a label, like if we're developing a CKD, chronic kidney disease model, and we're using a label like EGFR, which that's actually a measurement that has a racial component that's built in. So if we were to use that as a label, then we might find that particular label performs at I'm going to make up some numbers here, but it performs at an 8x lift for a white population, but at a 4x lift for a Black population. Ultimately, what you're wanting to do, once you have determined what that label is, you want to then measure the impact that it has, how well it performs for your racial subdivisions. So sometimes you might not, even if you don't necessarily know why, let's say that I introduced this if I just used cost, if I had used that algorithm and I had just asked the basic question, how well does this perform for certain subpopulations? Then I start to see, well, the lift score, the rating, I'm using lift. There's a number of different terms that you could use, but if I identify that the lift score for one group is much less than another group, then I know that there might be a problem with that label, or there might be a problem with my different approaches. But basically, they're by quantifying this, by acknowledging that it's a problem, and by working on it, you develop systems where you're focused on using that performance across races as part of your selection criteria for whether or not you should pursue a label. So if you're testing a bunch of different labels, you want to keep experimenting until you find something that makes sense. It's actually related to the problem that you're trying to solve, such as how sick somebody is or how likely they are to contract a certain illness. So the label has to be related to the problem you're trying to solve, and it has to It has to result in the model that performs well across these various groups.
This podcast is sponsored by Brown Rudnick's Global Life Sciences Group, a team of legal professionals that help life science companies, lenders, and investors around the world turn good science into good business. Learn more at brownrudnick.com. This podcast is also sponsored by Canon Quality Group. Canon Quality Group has been helping medtech startups set up quality management systems for over 10 years. If you're unsure when to get started with quality management in your startup, turn to the experts at canonqualitygroup.com.
So understanding the context is key, I assume. But what you're saying, when you're measuring different, then you go back to the data and look how it compared to different race. How do you, certain diseases affect certain race more than other. So that might also sway the result. But you need to have that understanding as well to see whether the data that came out from it is valid or not.
Yeah, that's correct. So certain diseases that impact races differently. Let's take melanoma, for example. As a Black person, I have a risk for melanoma, but I'm significantly less likely to contract melanoma, skin disease, than white patients likely are. So that's a component that, well, if this model is extremely good at predicting melanoma for white patients and less accurate at predicting for Black patients, you do acknowledge at that point the lower prevalence, the lower likelihood that Black patients would contract melanoma, but you still want to make sure that whatever your performance threshold is, such as a lift score, like that they're exceeding a minimum threshold, because the risk is still there. Mm-hmm. We're less likely to contract it, but there's still a risk, and I would argue that like a lot of the time, some of the precautions that help prevent it, such as properly applying sunscreen and things like that, like there still needs to be communication about preventive measures that go out to those populations too. So right. It's basically about establishing your metrics and making sure that you're beating those thresholds for your models.
And I think you don't want to also be dismissed when you showed up with certain symptoms, saying that, well, the chance of you getting it's so low, so they kind of brushed it off and it turned out to be not good. And I always worry when things become generalized and then you showed up and the doctor's like, oh, don't need to worry about it because you don't fit that population.
Yes.
And that's always very disturbing. Statistic is important, but it's the thing sometimes we as a patient got quoted statistic until you're like, 1% chance, and you're that 1%.
Exactly. I love it that you said the word generalized. Generalized worked for when we wanted to, like when all we had was enough computational power to like segment and go down to like these large swaths of population. But now communications are individual. Things can be made specific to me. So we should be getting away from generalized and towards personalized.
I know we can talk a lot about this, but I felt like I should at least ask you, like, how, your work now at SymphonyRM, how is that addressing a lot of the things that we talk about?
It's specifically that. So I'm working along with the data science team on like the things that we're talking about, such as label choice bias and acknowledgments of systemic and financial bias. These are things that we're working on and incorporate into our data science pipeline. So where like kind of before we started this work, we kind of had a knowledge that like this might be happening, that algorithms could start showing bias and reflecting the bias that's within healthcare. But when we started examining that, we saw some real clear opportunities to work with it. So at SymphonyRM, and I'm really happy to be working on this, excited that we've been given the green light on it. It's a matter of, okay, so now that we understand this bias exists and we understand some causes of it, what are the processes that we change in terms of how we collect data and the data that we collect? Are we collecting information on race and ethnicity? Are we able to collect information on things like sexual orientation, gender identity that might have other areas that are showing bias as well? And then on down past the data collection, how are we working with our algorithms? And even outside of that, since at SymphonyRM, our focus is on the products that we deliver are within the healthcare space and require like guidance from our teams and customer service group on how to use them. We have to give a deployment not just with the algorithm, but how our employees understand, how our clients understand, how we discuss this stuff in the market, how we educate healthcare leaders, and how we educate the people that we're working with to make sure that they understand the importance of removing bias from not just the algorithms we deliver, but from the business approaches that they're taking.
Can you give us an example, like a case study that you can share, like how the work that you do at SymphonyRM apply, like a real world example that we can like, oh, that's what you meant.
I really should have started with what SymphonyRM does in general. So let's take an example of I always bring up cardiology campaigns. It's always on my mind. And the basic concept is, let's say that I have, I'm a health system that serves, let's call it 7 million patients. And we know that, like, as this health system, I offer 76 different services. One of them is cardiology. And one thing that I want to do is make sure that the patients that I serve, of these 7 million patients, the ones that have this particular need, this risk for needing cardiology services, this risk for heart disease, we want to intervene with them early so that this doesn't cost them more. This doesn't become something that's a more significant pain to them on down the line. So we want to, our goal here, the problem that we're trying to address is, of our 7 million patients, who should be reaching out to for cardiology consults and services and things like that. So we outlined earlier kind of like if I'm a marketer, or if I'm in patient engagement or outreach or whatever group is charged with making this patient population aware, the typical method is to take a few demographics, general demographics and things like that that we were talking about earlier, like these approaches, like, well, we know that on average, men are more likely to have heart problems than women. And we know that that generally impacts people that are 45 years and above. So that's the market we're going to reach out to. The problem with that is for all the people who are not men. Like if I am now saying, okay, I've sliced these demographics, I've got this general idea, and I'm going to send out my heart communications to those people. Well, if I'm not a man, I'm not getting the communication. And if I'm below 45, I'm not getting the communication. Does that mean that I don't have a potential need for heart services? Absolutely not. So what SymphonyRM is focused on is using much more data than that, allowing much more nuance in that type of outreach to address complexities, such as, yeah, we know that people below 45 are less likely to contract that illness than people that are above 45. But what if their BMI is high, or what if their systolic blood pressure is in an abnormal range, et cetera? And the way that we help the health system identify all those nuances is to use a machine learning approach that takes into account the types of visits that people have had, what people have coded for in the past, and looks for people that are similar to that based on a whole slew of various biomarkers and demographic factors. So by using that, and I bring up that heart example because in a particular approach, like what we found was that that population that was below 45, between 18 and 45, that normally would not have received that communication at all. They happened to be 27% of the new people that were identified, that the new people that were booking visits by having that approach. So long story short, it's helping to use the nuances found in data to find who needs communications about certain services. And the way that it applies by race is, I think in the description or somewhere earlier, we talked about how an AI model might look like it's performing really well. But then when you break it down by race, when you break it down to how does it perform among white patients versus Black patients versus Asian, Latinx, et cetera, then you start seeing different results. So like in the cardiology example, one thing that happened when we applied that ethical AI and data science pipeline to it, we were able to increase the outreach to underserved Black and Asian populations by 23%. Within other illnesses by varying percents, but the basic idea, the basic concept of this framework is to consistently expand the outreach to people in underserved populations who otherwise wouldn't have gotten that important communication that got them to eventually come in for that cardiac consult or screening or other type of procedure.
Okay. Yeah. So you mentioned earlier about, understanding the context, right? You have all the data scientists who knows how to do all this algorithm, all the geniuses in math and everything. But having somebody who understands the context, the society, the sociology, and the anthropologies. How do you bring all that skill set together to inform, to make a, to convey the right information?
I would say lots of difficult conversations, but well needed. So the difficulty in the conversation is like you have one group that's really going to be focused on kind of the math of the situation and what kind of optimization method you're using, et cetera. And then you have another group that's wondering, well, how do I communicate this out to my clients or these health systems in a way that's going to get them to act and understand and not be offended that we said, hey, your data or systems or processes are showing racism to us. So you have to bring those groups together. Whatever type of company you're in, if I would say that I would say that if there's alignment between the technical team, the data science team that's going to be focused on the statistics, the product team that's going to be focused on what's the end user experience going to be, how are people going to use that, and your either implementations or your customer service or customer success group or consultants or what have you, you have to get them all in the same room. They have to buy into the importance of this process. And it has to be done in a way that, like, if it was completely something coming from the technical heads, like, hey, we developed this algorithm and it's making these suggestions, go use them. Well, in a lot of cases, people will see the suggestion and then say, and not use them because they don't really understand the context of that suggestion. So when you're coming up with my advice, if you're working on these responsible AI approaches, is to bring these groups together early on. Don't let it just be something completely isolated, because without that context understood by the people that are actually using and delivering this project, it doesn't matter how well your algorithm performs. It doesn't matter that you got the algorithm to perform really well across all these racial groups if at the end of the day, when somebody's actually using the thing, they're going to ignore the outputs. So that context has to be established. That agreement has to be established. As hard as it is, that understanding has to be established. It's not just responsible AI; it's responsible organizations.
And I think the context also will keep on changing, depending on the change in society, changing on new data. And I think can be also frustrating for some because people always feel like, oh, I'm done. But I think it's like, it's never done.
No. Yeah. And we're not done. We can't be done. So I feel like the moment that you do think you are done, you get comfortable, then that's when you're most apt to lose sight, most apt to let the guard down and let things go by. So yeah, you got to be humble, never done.
Yeah. So I know we're close to running out of time, but I want to ask you last things, like the whole healthcare equity, especially during the COVID, we see that more prominent in this country. How do you think the AI can help reduce the disparity in terms of the healthcare access?
So I think that it can play a part. At the beginning of the conversation, we talked about bias in the way that people in underserved groups have been treated in the past, and that's resulted in a lack of trust within healthcare institutions among minorities. And what does that lack of trust manifest itself in? Delayed visits, delayed screenings, delayed preventive measures. So if we're not communicating with our patients, and if we're not focusing on our underserved populations, then that perspective will continue. But if we're expanding our outreach, if we're really serious about looking at ways, looking at how these past disparities might have impacted the data that we've collected, and we're expanding our outreach to these groups, then we have some opportunity to find more people who are at risk and engage that communication with them. But it doesn't stop. In my opinion, does not stop with AI, because the same types of communications, the way that you might engage people from my background or my culture, might not be effective or even meaningful to how you'd engage other groups. So like the AI aspect helps you identify the people that you need to start these relationships with, but it's still pointing at more people who need that relationship. So it's kind of the point dog. It's saying, hey, let's think about how we expand our reach and work with these people. And at the same time, like if the approach, if this is done with more than just the data science team, more than just the people that are working on the algorithms, then hopefully we can find what that approach is among these groups who've been previously underserved to regain their trust and help build health equity that way.
Well, let's hope we keep making progress in that space. And well, thank you so much.
Appreciate that. Thank you.
Thank you for listening to another episode of the Health Technology Podcast. We want to thank our executive producer, Herminio Neto, and our podcast engineer, Andrew Rojek. If you enjoyed this podcast, be sure to subscribe and leave a review. The Health Technology Podcast is available on all major platforms.